Hey, what's up, guys? My name is Saurabh, and this is my YouTube channel, Data Science Novice. So, if you are new to my YouTube channel, please do like and subscribe. Your efforts are massively appreciated. So, in the last video, we talked about the data and we did some visualization as well. So, if you haven't watched that video, I would suggest you to go ahead and check it. I have provided the link into the description. So, in this video, we are going to build our own CNNs using Keras library. So, let's do that. So first, we are going to convert the target variable from numerical to categorical. And to do that, we simply import to categorical from keras.utils. Then we are applying this function on the target variable and saving it in the same variable. We have to do this because this is the specified format for keras to do the classification, else the model will not run. So let's run this cell. So now we have to make few imports to build our model. So the first import we do is model, that is sequential model. Because we are going to build a layer by layer model, so that's why we need to import sequential model. So next we are going to import different layers of our convolutional neural networks. So here we have dense layer, activation layer, convolutional layer, max pooling layer, and flattening layer. So if you don't know about these layers, I have written a blog post explaining each layers. So link in the description, go ahead and check it. So now let's build the model. So first we are going to instantiate the sequential model. And then we call add method to add layers in our model. So the first layer we are going to add is convolutional layer, that is conv2D, and it takes some inputs. So the first input it takes is the our image size. In that case, we have 28 by 28 with channel 1. That is a grayscale image. Next, we have how many filters we want. So you can choose any value you want. It's up to you. Then we have kernel size. Again, this size can be whatever you choose. You can choose 4 by 4, 5 by 5. It's up to you. So next we have detector layer. That is nothing but introducing an activation layer. And the purpose of this layer is to maintain a non-linearity in the data, that is non-linearity in the picture. So here we are using ReLU, that is rectified linear unit, as an activation function. So next we are going to add max pooling layer. So this layer serves two purposes. First, it makes the model invariant to special configuration of an image. That is, you can pass tilted image or inverted image. It won't have any problem detecting that image. And next, it reduces the size of our data. So in CNN, we can have multiple layer of convolutional layers. The more layer you add, the more complex will be the model and it will take more training time. So should be a fine tune between number of layers. So let's add a new layer. So just copy paste the above layer. So this time you don't need input size because that will be taken from the previous layer automatically, and everything else remains same. So you can change the kernel size, you can change the number of filters. Here I have taken 128 and kernel size is 3 by 3. And next we are going to add the same layers that we added in the previous layer. And another thing is that you can add as many layer of pooling as you want. So in the next layer we can add another layer, but that is something you will be doing, not me. So let's remove this. So now we have to connect the convolutional layer to our artificial neural network. And to do that, we use flatten layer. So what flatten layer does is it simply converts the data into one dimensional array, because this is how our artificial neural network takes the data. So let's add that too. So now let's create our ANN, and to do that we call dense and passing unit is equals to 512. That is, that layer contains 512 neurons. And next we again add activation layer just to make sure that it does not passes any noise. So now we are going to create an output layer so that we can get our outputs. Okay, so calling dense again, and this time we are passing unit is equals to 10. 10 because we have 10 outputs, right? So next we are going to convert the output from these neurons into probabilities, and to do that we add activation layer, and this time we are going to pass softmax activation function instead of ReLU. So this function just returns the probabilities of the outfits. So now we are one step away from building our CNNs. So next we are compile the model, that is on which parameter we want to train the model. And this take few parameters like loss, that is how loss should be calculated. Since it's a multi-class classification problem, we used categorical cross entropy. Next we have optimizer. So how do we want to reduce this losses? And to do that we use Adam optimizer because it works well for this problem. And next is the matrix. On what matrix we want to assess the model. So here we choose accuracy. So this is how we build CNNs using Keras. So next we are going to train the model on training data. So let's do that. So here X and Y's are my features and target. And then we create a validation set just like we use train test split method. Okay, so here validation size is 0.3, that is 30% of the data is being used for validation. So next we have epochs, that means how many times you want to pass the data to the model. So here we are setting it equals to 30. Next we have batch size. So generally we don't pass the data as a whole, we passes it into the batches because this way model train faster. So setting the batch size equals to 32. Okay, so let's run this cell. Okay, so we are getting some error. So this is not validation, so it's a validation size. So let me correct it and then we will run it again. So the model has started the training. So it will take some time to train the model. And if you haven't subscribed to my YouTube channel, please do like and subscribe and press the bell icon for the future updates. So I'm going to fast forward in time. Okay. So the model has trained now, and here we see that the training loss is 0.0219 and the validation loss is 0.83 and the training accuracy is 0.9931 and validation accuracy is 0.09, sorry, zero point 0.9. So here we see that our model is performing better on training data, not on the validation data, and this is known as overfitting. So in the next video, we will learn how to check whether model is overfitting or not using graphs. And we will also try to solve the problem of overfitting using dropouts and early stoppings. So that's all for this video. If you enjoy the video, please do like and subscribe and press the bell icon for the future updates. So bye and stay safe.